Welcome to Logic Byte Academy. Today we're going to talk about conversions from octal, hexadecimal, and binary numbers to decimal number. There is only two steps involved in converting a number from any other number system to decimal. So the first is multiply each digit of the number by its base to the power of its place value. And then the second step is add the products that you get from the first step. Now let's take a look at how to convert an octal number to a decimal number. Octal numbers are base 8 system, so here our base is 8. So the steps involved in this conversion is multiply each digit of the number by its base, which is in this case 8, to the power of its place value. That means if we have a digit 2 at the first place, we add 2 into 8, which is our base, to the power of 1 to get the answer. And whatever we get from the first step, we just have to add the products in the second step to get the decimal value. So let's take a look at an example here. We have a number 102, and so 2 is in the 0th place, 0 in the first place, and 1 is in the second place. So to add this, we have 1 into 8 to the power of 2. 8 is our base and 2 is the exponent. And the second, 0 into 8 to the power of 1 and 2 into 8 to the power of 0. So the answer would be 64 plus 0 plus 2 into 1. That would be 2. So the answer is 66. Take a look at another example here. We have another number which is 713 in octal. Here the place value of 3 is 0, the place value of 1 is 1, and place value of 7 is 2. The answer is going to be 7 into 8 to the power of 2 plus 1 into 8 to the power of 1 plus 3 into 8 to the power of 0. So the answer is going to be 448 plus 8 plus 3 is equal to 459 in decimal. Now let's learn how to convert a number from hexadecimal to decimal number. Hexadecimal number system is a base 16, so it has 16 numbers, 0 to 9 and 8 to F. To convert, we just have to multiply each digit of its base, which is 16 here, to the power of its place value and add the product. So we can do an example here. Here we have a number 6851 in hexadecimal. Here 1 is in 0th place, 5 is in 1st place, A is in 2's place, and 6 is in 3's place. So the answer is 6 into 16 raised to 3 plus A into 16 raised to 2 plus 5 into 16 raised to 1 plus 1 into 16 raised to 0. So that would be 6 into 4096 plus A is 10 in decimal, 10 into 256 plus 5 into 16 plus 1. So the answer is 24576 plus 2560 plus 80 plus 1. Answer is 27217 in decimal. Another example, we have BAD in hexadecimal. Here D is in 0th place, A is in 1's place, and B is in 2's place. So B into 16 raised to 2 plus A into 16 raised to 1 plus D into 16 raised to 0, which is equal to B into 256 plus A into 16 plus D into 1. So which is equal to B is 11 in decimal, 11 into 256 plus 10 into 16 plus D is 13 in decimal, 13 into 1. So the answer is 2816 plus 160 plus 13. The final answer is going to be 2989 in decimal. Now let's take a look at how we can convert from binary to decimal. So here the binary is a base 2 number system. So here our base is 2, and so the step is going to be multiply digit by its base. Here we have its 2 to the power of its place value. So the second step is add the products. And for example, here we have a number 11 0.011 in decimal. So we can now assign the place values for each digit as 0, 1, 2, 3, 4. So the answer to the conversion is going to be 1 into 2 raised to the power of 4 plus 1 into 2 raised to power of 3 plus 0 into 2 raised to the power of 2 plus 1 into 2 raised to the power of 1 and 1 into 2 raised to the power of 0. So it's going to be 16 plus 8 plus 0 plus 2 plus 1, which is going to be 27 in decimal. So let's take another example. Here we have another example, 11000 in decimal. We have the number place values written there. Here we have 1 into 2 raised to the power of 4 plus 1 into 2 raised to the power of 3, which is equal to 16 plus 8, which is equal to 24 in decimal.